In this video, we're going to look at some specially designated methods that are also potentially part of any class that we create, the class method and the static method. These methods are not only specially designated, but they also have special functionality that we can invoke. Now, we discussed a class variable, and I wonder whether you can, or class attribute, same thing. I'm wondering whether you can identify the class variables that we have in my class, just as a little bit of a quiz. The two class variables that we have here are instance counter and init. Both of them are variables that were defined inside the class, and so they are part of the class as class attributes. As we saw, you can access the class attribute through the class itself. For instance, if I say myClass.instanceCounter, I'll get 0. And also through any of the instances. If I say y.instanceCounter, I should also be able to see 0. And we could run that to be sure I'm not missing anything. And there they are, the zeros. Okay. Now, it is true that these attributes are available from both those two places. But if we're interested in, that is through the class itself and also through the instance, but if we're interested in working with one of the attributes, a lot of times what we may choose to do is create a special kind of method that's designed to work directly with the class object, that is, the thing that we see when we see my class. Again, as I showed you before, when we say myClass.instanceCounter, we are accessing one of the attributes of the class. There is a specific kind of method that we can create that may work with this, and it's called a class method. Now, what we're doing in instance counter is we are going to set up a classic variable that they use to talk about class attributes in textbooks, and it is as an instance counter. I don't know if you can tell what we're going to see here if we try to take a look at the instance counter variable after having created these instances. Well, as you can see, you have an opportunity, of course, to pause if you want. But as you can see, we're creating two new instances. Now, as we saw earlier, every time we create an instance, or rather more specifically or more accurately, construct a new instance, Python's going to call init within the class. And that's the case here too. In both line 13 and line 14, init is being called automatically. During that time, of course, when we're calling init, two things are happening now. One, we're setting the name, the person name attribute in the instance. But secondly, we are incrementing the value of a class variable. That class variable is being accessed through the name of the class. But there's another kind of way that we can work with the class variable using a specially designated method. And that is something called a class method. So if we say, let's say, get counter, and maybe, actually, I'd like to see if PyCharm acts differently if I do it this way. I'm going to give this class a special decorator. You may remember that decorators will affect the way a function works. Okay, notice that after I designate this, I decorate this method with the class method decorator, PyCharm acts differently. When this is just PyCharm trying to be convenient. When I type my parentheses to start my arguments list for this method, PyCharm pops in CLS instead of self. That's because CLS is the class itself. And if I wanted to, let's say, return the value of the instance counter, I could say CLS.instanceCounter. Now this may seem a little redundant since I'm able to access this instance counter in many different ways, but you never know what additional functionality might be added to this method. All I want to do in this case is just illustrate the way a class method works. And let's look again at the class method definition. A method that is designed to work with the class object rather than the instance object. So you may compare me getting the instance counter value from my class. In fact, CLS in the method and my class, the name, are actually pointing at the same named method. The same named class, the same class object. So saying CLS.instanceCounter and saying myClass.instanceCounter are actually the same thing. CLS is the class object. And a class method is designed to work with the class object, not the instance object. Now you may reflect that it is also possible to get instance counter from the instance, so I could be using the instance as well to get the instance counter. But the idea here is that it's going to be cleaner and make more sense for me to ask the class itself for its attribute. And again, as we see, it is also possible to use the class name, but sometimes we like to avoid using the class name in case it should change in the future. So we have the class method, which allows us to work with the class object directly and can be called from the class or from the instance. So maybe now, instead of doing this, what I'll do is I'll call x.getInstanceCounter. And this should give us the value 2 since we incremented the instance counter twice, once for each time we created a new instance object. Now again, like some of the other things that you've seen, it may be challenging to put this into context when you don't see a practical need for it. Just understand that it's another part of the mechanics and it may become useful to you in the future. The last type of method that I'd like to show you is something called a static method. And I'm going to give you a similarly meaningless example. Just imagine that we wanted to create a method that does some utility thing for us, like let's say add two numbers together. It's not the best example. In fact, it's not a very good example at all, but understand that the static method has its own specific kind of way of working. And if I were to, let's say, print x dot add these 5 and 10, we should get 15 because we're using this utility method. The utility method, static method, is just a method that isn't really designed to work with the instance or the class. Instead, it's designed just to work, to do a regular function sort of thing. But the reason we include it is because maybe what it does is related to what the class does. And so it kind of belongs in the class. It's sort of like part of the class. It's like a utility function that's part of the class's work. So we don't want to put it outside the class. We'd rather keep it inside the class. However, it's not an instance method that takes the instance. It's not a class method that takes the class or works with the class. Instead, it's a method that's not designed to do either of those things. Instead, it just takes arguments and it does its work. So now we've looked at three kinds of methods. We've looked at the type of method that takes the instance as an argument. And don't forget, we had other methods that weren't init that did this. For example, greet, which just prints hi and then self.personName. That's also an instance method. We then have a class method that works with the class and a static method that doesn't work with the instance or the class. Instance methods, like the two that we have here, are the most common. They work with the instance, and so they take self as the first argument. Class methods are designed to work with the class, and so they take CLS as a first argument. And we know that that class will be passed automatically when we decorate the method with class method. And static method is just like a utility method that does not work with either object and can just do work on its own.